In the previous video, we created a service account, assigned the required IAM roles, and securely stored the credentials in Secret Manager. In this, we will prepare the WebGIS application for cloud deployment. We will upload the WebGIS project to cloud using Cloud Shell, verify that the application runs correctly in the cloud environment. We already set up the project structure. Let's look at the remaining files required for cloud deployment. The WebGIS project consists of several important files. app.py file contains the Flask application and API routes. config.py file manages the Google Earth Engine initialization and application configuration. requirements.txt file contains all Python dependencies required by the application. The Dockerfile will be used to package the application into container for deployment. The templates folder contains the front-end HTML files used by the application. Now let's upload the project to the Google Cloud using Cloud Shell. Cloud Shell provides a browser-based Linux environment directly within the Google Cloud, which allows us to manage files and execute commands without installing anything locally. So to access Cloud Shell, we have to first go to the top right of the Google Cloud console, click the Activate Cloud Shell icon. When the pop-up appears, click Authorize to grant permission. Then we will upload the WebGIS project folder into the Cloud Shell. Select Project folder and Files and upload it. Once uploaded, using cd command, we can move into the project folder WebGIS app. Then we can use the ls command to list all the files and folders in the current directory. Before making any changes, let's install all the required Python libraries using the pip install or requirements.txt command. This command reads the requirement file and install all the dependencies needed by the application. Now let's test the application within the Cloud Shell local environment. Using Python app.py, we can start the Flask application and verify the application is working correctly. Once the terminal confirms the local deployment is successful, click on the link http localhost 8080 to open the application in your browser and verify it runs smoothly. Now we have verified the application is working. Let's understand the changes we made in codes for deployment. Let's look at the config.py file. Open the file typing nano config.py on the Cloud Shell. Config.py file handles the project settings. It defines the study area, configures the WebGIS application, and securely connects to the Google Earth Engine. Unlike local setup, for cloud deployment requires a few changes for security. So we import Google Cloud Secret Manager library. Instead of putting sensitive credentials directly in the code, we store them securely in Secret Manager and fetch them when needed. Here we define the project ID and the secret name within the function initialize EE that holds the service account key. Next, this line of script logs the startup message and records the time so we can track how long initialization takes. Then a try block connects to the secret manage to fetch the secret key, then parse the JSON data into Python. Using secure credentials, the script initializes Google Earth Engine. Finally, we define the region of interest, set common processing parameters like scale, maximum pixels, and create a function to those coordinate into a Earth Engine geometry. Next, let's look at app.py. Type nano app.py in Cloud Shell. Most of the code here, such as the Flask routes, Earth Engine workflow, NDVI calculation, and map visualization, is exactly the same as what we covered in the local deployment videos. For cloud deployment, we only added a few important features. First, we import Flask-Limiter. This is a common practice in cloud applications to manage incoming traffic and prevent excessive requests from reaching the server. We have also added specific limit of 10 requests per minute to the getStats endpoint. So this endpoint performs NDVI calculations and other Earth Engine processing tasks which can be more resource intensive than standard requests. So these values only example for this tutorial. As your application grows, you can adjust the rate limits and security settings based on the project requirements. Next, let's understand the Dockerfile. A Dockerfile is a set of instructions that tells Google Cloud how to build and run the application. Open the file typing nano Dockerfile on the Cloud Shell. First, we use a lightweight Python 3.12 environment as the foundation for the application. Then we create a working folder called app inside the container. This is where all the project files will be stored. Next, we install the required system dependencies. After that, we copy the requirements.txt file and install all the Python libraries needed by the WebGIS application. Once the libraries are installed, we copy the remaining application files into the container. Next, we configure port 8080, which is a port used by the Google Cloud Run to communicate with the application. Finally, we start the application using Gunicorn. Gunicorn is a production web server used for cloud deployment. In summary, the Dockerfile prepares the Python environment, installs all required libraries, copies the application files, and starts the WebGIS application so it can run on Google Cloud Run. Next is the requirements.txt file, which tells Google Cloud exactly which libraries need to be installed for the application to run. Most of these libraries are exactly what we use for the local deployment. For the cloud setup, we only need to add 3 new ones. First is Gunicorn. This is a production grade web server that runs the Flask application. Next, we have Flask-Limiter. This manages the traffic flow by setting simple request limits. Finally, we add the Google Cloud Secret Manager library, which allows the app to securely fetch the service account key from the cloud. The rest of the requirements file contains the standard Flask, Google Auth and Earth Engine packages that we have already familiar with during the local deployments in the previous videos. At this stage, project folder is uploaded, the libraries are installed and everything is tested and ready to go. In the next video, we will build the container image, push it to the artifact registry and deploy the WebGIS application onto the Cloud Run. Subscribe and enable notifications to stay updated with the upcoming videos in the series. Stay tuned. Happy mapping!